Welcome back to Unit 6. Today in Unit 6 we're going to be talking about relations and vocabulary. So let's go ahead and get started with that right now. Today we're going to be continuing the functions unit. We're going to be talking about relations and other types of vocabulary. Let's take a look at a few things that are important to remember. In the last set of notes, we talked about relationships that were linear equations. So we've been looking at relationships that have been linear. This means they've all formed a straight line. But not all relationships make a line. Some are non-linear, where they don't make lines. Sometimes they're just points on a graph. So let's talk about exactly what a relation is. A relation is a relationship between two sets of data. So for example, height and weight, age and height, those are two different sets of data, but there is a relationship between them. However, relationships are not always linear. So far, we've looked at relationships that are only linear, but that doesn't mean that all relationships are always linear. Let's look at example A. So again, example A says, look at the relation below and graph the data in the table. So we're comparing our two sets of data. In this case, we have the number of items purchased at Target and the money spent in dollars. So we're going to start by graphing our points on our line like it tells us. Then we're going to answer a couple questions. So we have 8, 5, so we're going to go over the number of items 8 and up to the amount of money spent, which is just in the middle between the 0 and the 10 at 5. Then we're going to go over to the 14 items spent, and they spent $40, so we're going to bring our dot up to the 40. $60 spent on 2 items. And finally, 6 items for $35. So let's take a look at our graphs on our point. Now, should we connect these points? Well, they're not really making a line. They're kind of all over the place. So we're not going to connect these dots. Then it tells us to write this relation as a set of ordered pairs. So I'm going to write down all of the relations in the graph in an ordered pair. But notice how I write them down. I start with the x value and I go from order to least to greatest. Not the order that's shown in the table, but the order of the values is from least to greatest by the x value. So 2, 6, 8, 14 is in order from least to greatest. So when the question asks you to write the relation as a set of ordered pairs, remember, you need to write them in order from least to greatest based on the x value. Let's take a look at the next one. So example B says complete the table based on the relationship below. So this time they've given me a graph. Last time they gave me a table and told me to put it in a graph. This time they've given me a graph and they would like me to put it in a table. So it says the Math 8 students, and across the bottom it says their ages in years, and then how tall they are in inches. So I'm going to start by labeling my table. So I need to have an X and I need to have a Y. Since ages is across the X-axis, that's going to be my X. And since height, inches, is along my y-axis, that's going to be my y. So my height in inches is going to be my y. Now again, I'm going to put my order in table from least to greatest. So the smallest number I have for x's is 12. I have 2 of those, so I'm going to write 2 number 12s. Then I'm going to move over. I have 113. I have 114. No, I have 2 14s, so I'm going to write 14 twice. And I have 115. Now I'm going to do the same across the y's and match. So 12, I have a 62. So 1262. I have 1265. 13 is at 73. 14 is at 64 and 70. And my 15 is at 66. So notice I took all of the data from my graph and I went ahead and I put it on a table. the data didn't change. I didn't change what was represented. What I changed is the way that it was shown. So both are the same relationship, just shown a different way. Now let's take a look at some vocabulary terms. Alright, so here we have two sets of data. We have the number of people and the number of animals, and their relationship, they're going to be compared to one another. So the number of people is going to be our x. It's the first thing we're going to be talking about. So it's our x. The other part of our relationship is the number of animals, so that's our y. We don't just call these things by letters. We also have words to describe them. The words to describe the x is input. The word we use to describe the y is the output. Every time you're talking about the x, you'll be talking about the input. Anytime you'll be talking about the y, you'll be talking about the output. Now there are other words that we use to describe the x and the input, or the y and the output, and some of those words are on the right-hand side here. So we're first going to start about the domain. Whenever you're talking about the domain, you're talking about the set of all of the inputs, not just one of the inputs. So for example, 4 is one of the inputs, but we're not talking about one, we're talking about all of the inputs. So I'm going to list all of the inputs in order from least to greatest, and I'm going to use my set notation. Those are those little brackets on the end. Remember, whenever you're asked to write the domain, you need to write it in order from least to greatest, and you must use those set notation brackets. Otherwise, your answer will be marked incorrect. The next thing we're going to talk about is the range. And the range is the set of all outputs. Now, I know you've heard range before, and you're like, I think that's like the biggest minus the smallest. When we're talking about functions, range speaks about the set of all outputs. And again, if you're asked to talk about all of the outputs, you're going to list them in order from least to greatest, and you're going to use set notation. So that's how we would describe all of the numbers, but what if we're talking about the words, like the number of people and the number of animals? We have titles for those. We talk about the independent variable. The independent variable is the x, or the domain, or the input. Those all mean or are talking about the same thing. So the input is the letter or description that represents all the inputs. So in this case, we're talking about the number of people. The number of people is our input, and the letter that describes them for the x. For the y, we talk about the dependent variable, and that's the letter or description that represents all the outputs. And in this case, that's the number of animals. Is it always number of animals? No, it's whatever is being used to describe the y values. So let's practice a little. So here we have to fill in our boxes. It's asking us for independent variable, or dependent variable, or domain, and our range. So I know the independent variable is talking about words, and it's talking about words to describe the x value, or the inputs. So in this case, that's going to be the inches of snow, as that is the thing that is listed first. Then it's asking for our dependent variable. And our dependent variable is the thing that's going to be listed second. We're talking about our y, and in this case, that's the number of snow days. Then it asks for the domain, and I know the domain is going to be a list of all of the inputs, all of the x values, in order from least to greatest, with my set notation. So I know my smallest number there is 3, then 8, then 15, then 21. But wait, there are two 15s. Why did I only write one 15? Whenever you're listing the domain, you only need to list all of the inputs in the domain. You don't have to list 15 twice because you've already listed it once. A good example of this would be if I were to ask you what you had for lunch last week, and you had pizza 2 days that week. You would still just tell me pizza. You wouldn't say pizza pizza for the number of times that you ate it that week. So the next thing asks us for what is the range of the relation. And the range of the relation is whatever the y values are, or all of the outputs. So again, I'm going to write them in order from least to greatest, and I'm going to make sure to use my set notation. Excellent. Let's look at the next one. Alright, this time they've given us the data as a graph. Now again, it's just showing us a different way to show the data, but it doesn't change what we're looking for. We're still looking for the independent variable, dependent variable, domain, and range. I want you to pause the video now, try it for yourself, then unpause it to see if you are right. How did you do? Hopefully you knew that the independent and dependent variable are where the words go, and domain and range where the numbers go. Let's take a look at the next one. Now in example D, they've answered the questions based off the table. So they've given us 4 different tables, and they said which table has the domain of -2, 0, 4, and 5, and which table has a range of 3 and 4. So the way I'm going to do this is I'm going to look at the domains first to make sure that they have every one of the domains listed. So for example, table number 1 does not have a -2 in it, it doesn't have a 0 in it, it doesn't have a 4 in it, and it doesn't have a 5 in it in the x values or in the domain. So I know table number 1 cannot be correct for the first problem. The second table has -2, 0, 4, and 5. It has all of the domains that we're looking for. It has all of the x values. So number 2 is probably correct, but let's just check number 3 and 4 to make sure. Number 3 has a -1. That's not listed in our domains, so that can't be correct. And number 4 also has a -1 in the domains, so that's not going to be correct. So the only correct answer is table number 2. The next one says, which table has a range of 3 and 4? So again, I'm going to compare this time the outputs to make sure they match. Now table number 1 has a 3 and a 4, but it also has a 5. And the question doesn't ask me which has a range of 3, 4, and 5. It wants just a range of 3 and 4. So although it has the 2 numbers I'm looking for, it has extra numbers. So it is not correct. Table number 2 has a -1. That's not a value we listed. Number 3, again, it has a -1. Not a value we're looking for. Oh, the last one has 3 and 4. Oh, but look, it has 2 3s and 2 4s. And I'm only looking for 1 3 and 1 4. But good news, whenever I'm listing the domain or whenever I'm listing the range, I only have to write down the number once, even if I have it multiple times. So number 4 is correct because it only has 3 and 4 in the range. Take a look at the next practice problem. Practice number 3 says answer the questions based off the tables. So it asks you to select all the tables that have a domain of -1, 2, and 3. So this time there might be more than one right answer. I want you to pause the video, try this problem for yourself, press play again to see if you are right. How'd you do? You should have gotten table number 1 and table number 4, because those have all of the domains that are listed. Let's take a look at the next one. So example E says, select all the sets of numbers that match this description. All the members of the set are members of the domain. So over here on my graph, I have a line that's graphed from +2 to +8. So those are the domain. Now yes, the line goes up, but I don't care about that because I'm not looking for the range. I'm only looking for x values. So I'm looking for x values that fall between the 2 and the 8 because that's where the line is covering on the domains. So my first one has 3, 5, and 6. So 3, 5, and 6 do fall between 2 and 8. So that is a correct answer. My next one has 1, 5, and 10. 1 does not fall between 2 and 8, and 10 also doesn't fall between 2 and 8. Now 5 does, but not all of the numbers listed are members of the domain. The next one says 0, 1, and 2. Again, 0 and 1 do not fall between 2 and 8, so that is not correct. The next one says 2.5, 4, and 7. So 2.5 is after 2, 4 and 7 are both before 8. So all of those numbers fall between 2 and 8, so they are correct. 8, 9, and 10. 9 and 10 do not fall between 2 and 8, so those answers are not correct. So those are the only 2 ones that we have for this problem. Let's try the practice. So this time it says, select all the members that are members of the domain. And this time the line appears to go between 1 and 4. Now yes, the line goes up, but again, we don't care about the range, we only care about the domain. Pause the video now, try this for yourself, then press play again to see if you are right. How did you do? You should have gotten 1.5, 2, and 3, and 2, 3, and 4. All fall within the domain of this graph. Thank you for watching this video on functions. If you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub, and we will catch you in the next one.